All right, let's look at 9.2 rational exponents. So last time we looked at radicals and we talked about the index and the radicand, which is under the radical sign. And we can write a radical as a fractional exponent. So sometimes when I'm putting a radical in my calculator, I'll do it as a fraction exponent instead of putting in the radical sign. So in general, if you have the nth root of a, so whatever your index is, now since there's no exponent written with this a, it's assumed to be 1, so a to the first power, and then the way you would write this is this equals a raised to this 1 is your numerator of your fraction, and then your index, in this case n, is the denominator of our fraction. So example 1 says express as a radical expression and simplify. So I have 64 to the 1/3 power. This is the same thing as writing it as the cubed root of 64. And then the cubed root of 64 is 4. The second one, we have 4x squared in parentheses, all raised to the half power, and that 2 means we have an index of 2, or it's a square root. And remember, we don't need to write that 2 for the square root of all of 4x squared, since all of that was in the parentheses. And then we're going to simplify this. The square root of 4 is 2. The square root of x squared, 2 goes into 2 one time. So 2x. This third example, negative 27x to the 6 to the 1/3 power. Again, all of this is in parentheses, so all of it is the cubed root, under the cubed root sign, of negative 27x to the 6th. And now we'll simplify. Cubed root of negative 27 is negative 3. 3 goes into 6 2 times. Now this last example, we have 15x to the 1/3. There's no parentheses here, which means 15, remember, is raised to the first power. It's only the x that's raised to the 1/3 power. So when you write this, the 15 should be out of the radical sign, and then the x is inside the cubed root. So 15 times the cubed root of x. Okay, let's look when you have an exponent besides 1. So in this case, we have nth root of a raised to the m power. So when you have an exponent in your radical, you write it as a. Instead of 1 over n, it would be m over n. So you still have your exponent as your numerator and your index as your denominator. So example 1 says rewrite using radical notation and simplify. So I have in parentheses negative 8x cubed all to the 2/3 power. So I can write this as the cubed root, that's my denominator, so that's my index, and then all of this is under the radical sign because of the parentheses, negative 8x cubed. And then you have a couple of options. The squared can be inside the radical sign, or you can deal with it after you deal with the cubed root. Either way is fine, it doesn't matter. A lot of times I do it after I deal with the cubed root because then I usually don't need to use my calculator. So let's take the cubed root first. The cubed root of negative 8 is negative 2. Cubed root of x cubed is x. And then we still have that squared. And then just remember you have to square everything inside the parentheses. So negative 2 squared is 4. And then we have x squared. Okay, b is different because it's, remember, 3 to the first power, x to the 2/5 power. It's only x that's raised to the 2/5 power. So the 3 will stay out of the radical sign. And then for the x, the index is 5. And then this is x squared. And then for c, it's all in parentheses, 64x cubed raised to the 2/3 power. So my index is 3. 64x cubed, and this is all squared. And again, I'm going to deal with the squared last. You can deal with it first if you want, it doesn't matter. The cubed root of 64 is 4. The cubed root of x cubed is x. And then this is all squared. 4 squared is 16. X squared is x squared. All right, when we have a negative exponent, we always want to simplify the negative exponent and make it positive. So the rule is to convert a negative exponent in the numerator to a positive exponent. You write whatever has that negative power, you write it over 1, and that changes the negative to a positive. So for example, just taking this example we have up there, a to the negative m over n equals, you write it over 1, you bring down the a, and then that negative becomes a positive m over n. So let's practice rewrite using radical notation and simplify. So negative 81 to the negative 1/4. So that negative is really kind of outside of the 81. I can leave it outside of it. And then to make this negative 1/4 positive, move the 81 down to the denominator, and then negative 1/4 becomes a positive 1/4. So it's negative 1 over 81 to the 1/4. I'm then going to simplify this. This is negative 1, 81 to the 1/4 power. You can do that on your calculator, or that's the 4th root of 81, which is just 3. So this simplifies to be negative 1/3. For the second example here, the 27a to the 6th is all in parentheses, which means all of this is raised to the negative 4/3 power. So when I write it over 1, I need to bring down both the 27 and the a to the 6th, and that negative 4/3 will become positive. And then we want to simplify this. Now the number you can do on the calculator, but I'll write it out. There's many different ways to do this one problem, so this is not the only way to solve this, the way I'm going to write it right now. But if I wrote this out the long way, this would be the cubed root of 27a to the 6th, and then this is raised to the 4th power. Okay. So that is going to become 1 over, cubed root of 27 is 3, 3 goes into 6 2 times, and then remember we're raising this still to the 4th power. So I get 1 over 3 to the 4th power is 81, and then 2 times 4 is 8, so a to the 8th. All right, let's practice a couple more. Again, there's many different ways to do this problem C. The way that I'm going to start this is distribute the negative 1/2 power through my parentheses. So this is the power rule. You multiply your exponents. So 8 times negative 1/2 is negative 4. And then 16 is raised to the 1st power. So 1 times negative 1/2 is negative 1/2. Now to simplify this, before I can deal with this half, I need to get rid of the negative exponents. So I'm going to move them. Basically, the y needs to move down to the denominator. So it's y to the 4th, and the 16 needs to move up to become positive, so 16 to the 1/2. And then we can simplify. The 16 to the 1/2 means the square root of 16, which is 4 over y to the 4th. Okay, here I wanted to show you the difference between having parentheses around both terms and not having parentheses. So when you start with this first example, all of the negative 8x squared is in parentheses raised to the negative 3/2 power. So that means when you write it over 1, the negative 8x squared all needs to move down, and then this negative 3/2 becomes positive. Now if I write this as a radical, it'll show you a little bit easier what happens. The index is 2, which remembers that's the square root of negative 8x squared, and then my power is 3. And you can actually stop here because the square root of negative 8, remember you can't take the square root of a negative number and get a real answer. This is a non-real answer. So we can't solve anymore. Okay, so let's look at the second example. This one's different because, again, the negative 8 here is to the 1st power. It's the x only that's to the negative 3/2 power. So I can have the -8, and that negative can be attached to it or in front of the fraction, it doesn't matter, over x moves down and the -3/2 becomes positive. So two very different problems. Okay, let's review a couple of laws of exponents to help when we're simplifying different radicals. So the negative exponent rule, and we've talked about this already, we're just going to write them in one place. The negative exponent rule says if you have a negative exponent, to make it positive, you move it. So if it's in the numerator, you move it down to the denominator. And this can also go the other way. If it's in the denominator and it's negative, to make it positive, you move it up to the numerator. Okay, the product rule says that when you have the same base, in this case I'm going to use a, but it can be anything, it can be a number, it can be a variable, as long as the base is the same. When you're multiplying, you add your exponents. The quotient rule, similar, as long as your bases are the same. If you're dividing, you subtract your exponents. The power rule says if you have a power raised to a power, you multiply your powers together. So m times n. And then the distribute powers, this is just a reminder that when you have more than one thing inside the parentheses, you need to distribute that power to everything. So, and this is when you don't have an addition or subtraction sign. So let me give you just an example. I'm going to put a number in there because that number a lot of times gets left out. Let's do 2a to the m, b to the n, raised to the z power. So there's no addition or subtraction sign in here, which means I don't have to worry about having a FOIL or anything like that. But I need to distribute this exponent to the 2, the a, and the b. So using the power rule, this would be 2 to the z, a to the m times z, and b to the n times z. Okay, so let's try a couple of examples using the law of exponents to simplify. So we have 9 times 9 to the half. These are the same base, and again, there's many different ways to solve this. I'm just going to use the law of exponents, which says when you have the same base and you're multiplying, you can add your exponents. So this is a 1. 1 plus a half is 3/2. I can then use my calculator, plug in 9 raised to the 3/2 power, or I can write this as a radical. This is the square root of 9 cubed. The square root of 9 is 3. 3 cubed is 27. And if you had put 9 to the 3/2 power in your calculator, you would have gotten 27 as well as your answer. Okay, for b, remember the 4 is its own base, it's raised to the first power. The only thing I can combine is those x's. Those are the same base. And I can add the 1/3 plus 2/3, which is 3/3, which you then want to simplify to be 1. So that just simplifies to be 4x. Okay, let's look at an example. The number of Earth days it takes a planet in the solar system to revolve around the sun can be approximated by the expression 0.4 d to the 3/2 power, where d is the average distance of the planet from the sun in millions of miles. Write this expression in radical form. So all I need to do is 0.4. The d to the 3/2 is what's under the d is what's under the radical sign. So the index is 2 and the exponent is 3. 2, that's 2 is the denominator, 3 is the numerator. B says the planet Mercury is an average distance of 36 million miles from the sun. To the nearest day, how many Earth days does it take Mercury to revolve once around the sun? So I'm going to use the original expression I had, and I'm going to plug in 36 for D. And then you should just plug this directly into your calculator. 0.4 times 36 raised to the 3/2 power. Just make sure when you put in that 3/2 power, you put in parentheses to show it's raised to this whole power, not just 3 and then divide by 2. So try that, and when you put it into your calculator, you should get about 86.4, but it says to round to the nearest day, so that would be approximately 86 days. Okay, and last example. This looks like it's going to be really complicated, but if you take it step by step, it actually works out pretty well. So kind of almost think of these radicals like parentheses, and I'm just going to deal with the inside radical first, which means I'm going to rewrite the other two. So I'm going to rewrite the cubed root, and I'm going to rewrite the radical sign. And I'm just going to deal with the square root of 4096. And when you take the square root of 4096, you get 64. And now I'm going to do the same thing again. I'm just going to deal with the inside radical, which is the square root of 64. So I'm going to rewrite the cubed root, and when you take the square root of 64, that's 8. And so then your last step is the cubed root of 8, which is 2. So all that simplified just to be 2.